The proposed OVT-MLCS has main following functions. 1. Mining MLCSS from input sequences effectively and efficiently. 2. Inspecting or analyzing the patterns and characteristics from mined MLCSS with the intuitive and/or precise manner. 3. Displaying and downloading the mined results with both the graph and text file. And 4. Viewing the sample sequences. Below, we illustrate the main functions and features of OVT-MLCS using a few example use cases. System input. OVT-MLCS exposes a browser-based graphical visual user interface, which provides 3 different sequences input ways. That is 1. Manual input. 2. Select a text file for the input sequences. And 3. Select a text file with multiple sequence samples. The 3 different input ways are input or file selection through the input sequence box of OVT-MLCS. In general, the MLCS problem has multiple solutions, and the number of solutions increases exponentially with the length of the input sequence. For long or big sequences, the number of solutions can reach tens of thousands or even more. Therefore, to meet the application requirements, OVT-MLCS provides 2 mining ways: exact MLCS mining and top-K MLCS mining. The so-called exact MLCS mining refers to giving all the exact MLCS results of the input sequences. Given an input sequence number 3, length 270, and alphabet A, C, G, T, OVT-MLCS will demonstrate the input character sequences, mining progress, and final MLCS mining results. Where all of the mining MLCS results are presented in the form of a compressed directed acyclic graph DAG that can be zoomed in or out with the mouse, in which the character sequence on each path is an MLCS of the input sequences. OVT-MLCS also shows the statistical results of the mined MLCSS, and the mined results are automatically saved in the form of text and DAG images for users to download and review. Moreover, OVT-MLCS provides the interaction function between the user and the mining results. That is, when the user clicks on a point node of the results DAG, OVT-MLCS will highlight its corresponding character in the input sequences with pink color, so that the user can observe its corresponding character and position. In practical applications, users may only be interested in top-K MLCS results. So OVT-MLCS provides users with the ability to quickly and accurately mine top-K MLCS results. Input the long sequences with number 3, length 2000, character set size 20, and a value of K between 0 and 1. The following demonstrates the top-K MLCS mining procedure and results by OVT-MLCS. The existing sequence alignment tools only display their calculation mining results and do not have the function of interacting and further mining the results. Unlike the existing tools, OVT-MLCS provides further interaction and observation, analysis of mined MLCS results. We believe that this function provided by OVT-MLCS will definitely promote the stronger and wider applications of MLCS. The following example demonstrates this capability of OVT-MLCS. Click the Insight from Results functional radio button of OVT-MLCS and select the MLCS mining results. OVT-MLCS will display the mined top 10 MLCSS in 2 ways: text and graphic stack. When the user clicks on one of the text MLCS results, the system will highlight the result on both the input sequence and the result graph DAG with pink color. From the highlighted input sequence results, the user can intuitively and clearly see the alignment, similarity, and other characteristics of the input sequences. From the resulting graph DAG, the user can see the common patterns of these MLCS results, that is, which are the subgraphs having a width of 1 in the graph without any additional calculations. In addition, the input text character sequence is also displayed in the form of line and pie charts, from which the user can intuitively explore the commonalities and characteristics of the input sequences. In practical applications, it is important to quickly observe and mine the common patterns, characteristics, etc., among a lot of MLCS results mined from long and/or large-scale input sequences. To this end, OVT-MLCS can online calculate and display some relative important information of the mined MLCSS, such as common patterns of the mined MLCSS, an edit distance matrix ED along with corresponding histogram chart, where a value in ED denotes the input sequence with a minimum edit distance aligned with the top 10 MLCS, from which the audience can observe and analyze similarities, features, and patterns of both input sequences in the mined MLCSS intuitively and accurately.